When starting a project, we're never quite sure how it will end. A familiar situation, isn't it? Everything might look good on paper, but as we all know, the devil is in the details. And I must say, it's rarely wrong. When it comes to NASA's Galileo mission, this adage hits the mark. In the entire history of astronautics, it's difficult to find a more problematic unmanned expedition than this one. It's strange that in the end, the probe still continued to work and sent megabytes of valuable information to Earth. So just what did it meet on its way? And what kind of breakdowns periodically jeopardized the successful completion of the mission? During a difficult and risky maneuver, the probe went through an epic event, the catastrophic collision of the Shoemaker-Levy 9 comet with the largest planet in the solar system, Jupiter. And this fact compensated for all the problems that arose, fully justifying the organization of an expensive expedition. Do you think it's possible for a person to realize the complexity of space travel to this huge ball of gas with its incredible gravity and deadly radiation belt? On Earth, most likely not. Such a voyage is associated with a myriad of surprises that cannot be predicted in advance. For understanding, let's mention the problem that Galileo encountered almost immediately after it left the Earth's surface. The device's huge umbrella antenna broke. This meant that the information that the whole world was waiting for with bated breath would not be available. In other words, the intellectual forces and huge financial resources invested in the mission were completely leveled. Experts say that one of the reasons for the misfortunes that constantly accompanied Galileo was outdated equipment, because the design of the probe began back in 1977 and it was only launched 11 years later. There were dozens of incidents, but at the same time, nothing prevented mankind from considering the Galileo mission one of the greatest in the history of astronautics. However, let's not fall into speculation. It's better to immediately turn to the facts. So, what are the milestones of the Galileo space probe's long journey? Rendezvous with asteroids. Almost at the very beginning of the journey, being in the asteroid belt, Galileo became closely acquainted with two representatives of this cosmic population. Their names are Ida and Gaspra. These are the first asteroids seen by scientists with the eyes of Earth probe cameras, especially from such a close distance. Naturally, unique photographs are of great scientific value. As for Ida, Galileo discovered a moon near it, which was in itself a sensation. This small celestial body, the moon, which is basically just a clunky-looking boulder, was named Dactyl. Ida itself is no more than 32 kilometers in diameter, and for comparison, the circumference of its escort reaches just 1.5 kilometers. By the way, this is the first moon discovered around an asteroid, and it was Galileo that found it. Thanks to the information received, astrophysicists have learned more about chondrite meteorites that periodically fall to the Earth's surface. Their sources are now considered to be S-class asteroids, to which Ida belongs. And what about the second asteroid? Galileo flew at a relatively short distance from Gaspra, 1,600 kilometers, and during this time it transmitted 57 images. In addition, the orbital and physical characteristics of the celestial body were studied in detail. It turns out that Gaspra is comparable in size to Deimos, the moon of Mars. The temperature on the surface of the asteroid reaches -92 degrees Celsius, and the age of the object is about 500 million years. Gaspra is completely covered with craters, and there are about 30 of them. Catastrophic meeting. The next event accompanying the mission of the Galileo spacecraft was the live footage of a spectacular disaster. We would never have seen it in all its glory if not for the probe, because the event took place on the opposite hemisphere of Jupiter from Earth. What disaster do I mean? We're talking about the collision of fragments of the comet Shoemaker-Levy 9. Galileo recorded the collision of 21 fragments into the atmosphere of Jupiter at a speed of 64 kilometers per second. The fragments fell for 7 days while the probe methodically filmed the collisions and sent photographs to Earth. At that moment, the device was at a distance of 1.6 astronomical units from Jupiter, about 240 million kilometers. It's amazing, but the energy of the explosions, traditionally calculated in TNT equivalent, exceeded the entire nuclear potential of the Earth by 750 times, and the gas clouds at the places where the fragments fell rose to a height of up to 3,000 kilometers. Is that really even possible? A fresh look at the Galilean moons. The Galileo spacecraft studied the 4 largest moons of Jupiter in detail. Now we can say for sure that Ganymede has a magnetic field and therefore a liquid hot core just like the Earth. In addition, the probe flew close enough to the celestial body to photograph its surface. Based on the data studied, astronomers have suggested that there may be an ocean under the crust of Ganymede. Before that, the Jupiter moon was once photographed by Voyager 2, but such detailed information was obtained for the very first time by Galileo. The next moon studied by Galileo was Callisto. The probe flew quite close to the celestial body and photographed its heavily cratered surface. The device found that the moon has no magnetic field, and many craters indicate the ancient age of Callisto. Was there anything strange among the observations? Yes, a dark rock of unknown origin was found in the lowlands, possibly due to the tectonic activity of the object. In addition, on Callisto, Galileo discovered a subsurface ocean, the depth of which exceeds 100 kilometers. At the same time, it's believed that it's absolutely dead, unlike the reservoir of Europa, but we're not sure yet. The probe circled Callisto 8 times and once passed at a record distance of 138 kilometers from the surface of the celestial body. What about Io, strewn with hundreds of volcanoes? Galileo also visited it, flying 102 kilometers from the moon. The priority target of the study was volcanic plumes, and the probe successfully completed the task. This unusual moon is distinguished by variegated colors due to the highest volcanic activity. Among other things, the Galileo apparatus found out that if an astronaut had miraculously landed on the surface of Io, it would have received a deadly dose of radiation of 3,600 rads. This is a lethal dose at which a person dies painfully from multiple internal bleeding. Also, the probe managed to fly through volcanic ejecta, rising up to 500 kilometers, and make the corresponding measurements, which significantly supplemented our knowledge of the Galileo moons. The device found extensive traces of the powerful eruption of Patera Pilana, which happened in 1997. Thus, mankind has formed an idea of the monstrous scale of the volcanic activity of this strange world. In addition to these moons, Galileo flew 200 kilometers from Europa and confirmed the presence of an under-ice ocean in which, as scientists suggest, life develops. Photographs of Europa's surface were additionally studied by people who've worked in the Arctic for years and stated that the researchers are definitely dealing with an ice crust. In addition, it's possible that ocean water in some places even flows over ice hills. The surface of Europa is dotted with lines, freckles, chaos, furrows, and other landscape clutter, indicating endogenous activity of a celestial body. Galileo circled Europa 12 times and was subsequently destroyed due to fears that the device would eventually fall on the unique moon and infect it with terrestrial bacteria. Are you surprised? Be patient. We'll tell you about this event a little later. In addition to the traditional Galilean objects, the probe also visited Amalthea. It's an inner moon of Jupiter and the third farthest from the gas giant. If you don't pay attention to the size, then Amalthea is more like an asteroid because it's a huge boulder of irregular shape densely dotted with craters. From Amalthea's surface, Jupiter doesn't look like a planet. It's a monstrous disk that dominates the celestial body. Unfortunately, the most detailed photo of Amalthea looks like a blurry shadow, although it gives a distant idea of what Galileo was dealing with. But does the value of the mission lie only in the study of the Galilean moons? Discoveries on Jupiter. You'll be surprised, but even the death of Galileo benefited science. When it was decided to destroy the probe, presenting it with a ticket to the deadly atmosphere of Jupiter, the mission organizers frankly cried. They had to endure too much to keep the spacecraft operational. Nevertheless, the inevitable happened, and data from the probe was transmitted until the very last second. But not only the probe, which had been orbiting Jupiter for quite a long time, made a significant contribution to astronomical science. In December 1995, the DESCENT probe, the passenger of the main apparatus, plunged into the inhospitable atmosphere of Jupiter. Of course, no one expected a long stay, but a lot of information that scientists received was worth such sacrifices. The device worked for about an hour, and during this time descended to a depth of 130 kilometers. Astronomers were in for a few surprises. For example, Jupiter's hurricanes blew at much higher speeds than expected, and the temperature of the atmosphere also turned out to be higher. At a depth of 130 kilometers, the probe recorded 150 degrees Celsius, although when entering the gas layers, instruments showed minus 80 degrees. Surprisingly, the supposed water vapor cloud layer was also missing. It had always been believed that the atmosphere of Jupiter was full of super lightning, but during the flight of the DESCENT probe, there were not so many of them. However, electric discharges were still recorded by the instruments and were 1,000 times more powerful than those on Earth. The Galileo probe also recorded the Great Red Spot, a global hurricane observed only through telescopes 3 centuries before, although the Voyagers clarified the picture a little. After all, it was previously believed that this was not a storm but a solid structure. So, despite all the difficulties, problems, and obstacles, the Galileo spacecraft became a real pioneer, fearlessly paving the way for other missions because it saw and learned a lot for the very first time. Those that followed it will be warned and prepared, and this is worth a lot. The dangerous and fascinating journey was filled with incredible events, but the one that recorded them died heroically in the stuffy atmosphere of Jupiter, so we'll never hear his call signs again. Are you interested in learning about a distant celestial object in the far reaches of our solar system on the threshold of deep space? Do you want to see another world, many of whose phenomena defy rational explanation and understanding? Then get ready for a long journey, because the chosen celestial body is located millions of kilometers from Earth. Welcome to amazing Triton, Neptune's most famous moon. Due to its considerable remoteness, very few probes have studied Triton in the entire history of astronautics. To be more precise, only Voyager 2 has flown past this celestial object. That happened back in 1989 as part of a transit journey past Neptune, the parent planet of the icy moon. Here's the first photo of Triton, obtained from the Voyager spacecraft. The image is singular and exceptional, as the Earth had never before received anything quite like it, especially from such an enormously distant locale. So, what exactly is it, this cold and nearly inaccessible world, Triton? Despite the short meeting, Voyager 2 discovered a number of unusual phenomena on the celestial body, for which modern science has not yet given intelligible explanations. As mentioned previously, this Neptunian satellite was revealed to the world in all its glory by the legendary Voyager 2 probe. It's noteworthy that Triton was the last object seen by Voyager 2 in the outer solar system before the spacecraft crossed its borders into the farther reaches. Unfortunately, the probe was able to capture this mosaic of images of only one of the hemispheres, the one facing Neptune at the time. The craft's short transit time through the Neptunian system simply didn't allow for more. From first glance at the numerous photos, it became clear the moon is one of the few geologically active objects within the outer solar system, and its surface is relatively young, its age not exceeding 100 million years. Unlike most solar system moons, Triton rotates counterclockwise and takes the place as the seventh largest of all moons in a relatively close environment. It's generally assumed that this celestial body is an alien to this system, having come from the Kuiper Belt long ago, later being gravitationally captured by Neptune. The first surprise that Voyager 2 discovered was the presence of a rarefied atmosphere around Triton. The cloud layer above the moon is approximately 100 kilometers thick. Measurements have shown that the atmosphere is predominantly nitrogen, with small inclusions of methane and carbon monoxide. Strikingly, its pressure, which was about 19 microbars when measured by Voyager 2, has increased significantly according to 2010 data and now varies from 40 to 65 microbars. The mechanism behind this phenomenon remains unclear. What can be said about the surface of Triton? It's very unusual. To understand this, Voyager 2 needed just the one short meeting with the celestial body. There are 12 types of terrain on the moon, from chains of craters and strange potholes to vast plains and cryovolcanoes. The image presented here shows dark spots, the consequences of the cryovolcano eruptions. Near the equator, the probe found an interesting object, similar in contour and structure to a frozen lake roughly a kilometer deep. You can see here that there's a small impact crater on its surface. Such formations may indicate that liquid has existed on Triton for centuries. The moon resembles a huge piece of ice with a diameter of 2,706 kilometers. The temperature on the surface reaches an incredible minus 235 degrees Celsius, which makes this body the coldest in the entire solar system. It's so frosty that even nitrogen falls in the form of frost and snow on the mountain slopes and valleys of the mysterious moon. During the visit to Triton, its polar cap was revealed to be truly huge and covered a significant part of the southern hemisphere. According to the data obtained, it consists of a mixture of nitrogen ice, methane, and carbon monoxide. Another important question: how is this hemisphere cratered? Voyager 2 discovered only 179 craters, while on Miranda, which is just 3% the size of Triton, 835 of them were recorded. This is in conjunction with the fact, as mentioned earlier, that serious geoactivity is indicated on this Neptunian satellite. Additionally, the interplanetary probe discovered something unusual and mystical on Triton, namely, a surface that's not found anywhere else in the solar system. This is cantaloupe terrain, or melon peel terrain. What provoked the formation of such a strange relief pattern? This location is considered the oldest on Triton. The area is completely covered with huge structures up to 50 kilometers in diameter, with rather smooth and high edges. Surprisingly, the funnels are characterized by a pronounced curvature, in contrast to the clear forms of standard craters. There are many theories as to the origin of such a relief, and one of them claims that its origin is associated with very powerful cryovolcanic emissions that periodically flooded this area, melting the icy crust. Later, it's theorized the substance hardened and cracked. Cryovolcanoes are an unusual phenomenon from the point of view of orthodox science. Their appearance is possible only under conditions of extremely low temperatures, when mountains erupt and instead of molten rocks, spew water, nitrogen, and other substances in both liquid and gaseous states. These Voyager 2 images show one of these eruptions 45 minutes apart. In the blurred image, a plume of particles can be seen rising up to 8 kilometers and drifting with the wind for a distance of about 150 kilometers. But where is enormous Neptune, which should be reigning supreme in the skies of Triton? The probe did thankfully capture this image of the blue planet. Here you can see what the gas giant looks like from the surface of the moon. It even shows the global hurricane known as the Great Dark Spot. The Voyager 2 probe succeeded in the impossible. The images it sent allowed scientists to create a relatively detailed topographic map of the distant moon's terrain. In particular, the following 10-kilometer resolution image helped tremendously in achieving this goal. But, alas, all things come to an end sooner or later, and so the fruitful mission of the probe inevitably came to its conclusion. Throwing a farewell glance at Triton, the apparatus literally flew away into the distance and night. If you look at this picture impartially, you might think that we're not facing the icy moon of Neptune, but our very own satellite. As you may know, Voyager 2 also carried on board a golden plate with recordings of human speech, the roar of volcanoes, the whisper of ocean surf, the voices of birds and animals, as well as playback of famous musical passages. But on Triton, apparently there's no one to hear these magical sounds, although astronomers do suggest the presence of a subglacial ocean on Triton, similar to the one that probably splashes under the crust of the Jovian satellite Europa. According to assumptions, Triton's subglacial ocean's temperature doesn't exceed minus 97 degrees Celsius, and it consists mainly of water and nitrogen. And it's true that in such a harsh reservoir, it's unlikely that life, at least as we know and understand it, could have originated there. Meanwhile, Voyager 2 is still continuing its journey through the inky darkness of space, and we should think on the following. If Earthlings don't organize missions to Triton in the near future, then after some while, due to the tidal influence of Neptune, the moon will gradually approach the planet, having reached the Roche limit, and will inevitably collapse down onto its gaseous parent planet. The moon will be torn apart, and a system of rings will appear around Neptune, several orders of magnitude more epic than those of Saturn. It will be quite a show. In this case, Voyager 2 will remain the first and only device to visit Triton at the outskirts of the solar system. If you want more videos on similar topics, tell us about it in the comments and click the like button so we understand that you like the content and we'll produce more informative mini films like this. And click on the bell, share the video with your friends, and let them also journey to unknown worlds with the Hubble channel. Have you ever turned your attention to an unusually bright star above the horizon in the evening? If yes, then it's likely you might be wondering, what is it? The answer may surprise you because this is not a star at all, but a planet. No, you heard right. This celestial object is nothing more than the closest planet to our Earth, Venus, the one that was named after the ancient Roman goddess of beauty. Although, in my opinion, it's too hot for the Romans. It turns out that you can see it by just going out into the street. And if you had at least a weak telescope, then looking at Venus, you would see not much of anything, because the planet's surrounded by an impenetrable cloud layer. By the way, for a long time it was assumed that the place was full of life behind these clouds, just like on Earth. But then in 1970, the Venera 7 probe landed for the first time on the surface of the alleged beauty, after which its cameras recorded a completely different picture. The first evidence that the planet turned out to be not as friendly as one might assume is the fact that the device lived on the surface for no more than 20 minutes. And before that, for 33 minutes, it had been transmitting indicators of the Venusian atmosphere to Earth. Without exaggeration, Venus can be called a real branch of hell in the solar system. The temperature on its surface can reach 460 degrees Celsius. But this planet can surprise not only with a truly warm reception. For example, Venus does not have a magnetic field, and it rotates in the opposite direction to most other planets, except for its brother planet Uranus, which is lying on its side for some reason, but that's another story. But that's not all. One revolution around its own axis, that is, one Venusian day, takes 243 Earth days, while a year lasts only 225 Earth days. That's right, a day on Venus is longer than a year on Venus. Under such conditions, the length of the day and night in the aggregate is 117 full-fledged Earth days. That's exactly where there might be enough time to get some sleep. Still, not a single moon accompanies the planet, although one presumably existed at earlier times. Where did the Venusian moon go? Nowhere. It's around. According to the observations of many astronomers, we can conclude that earlier Mercury was a moon of Venus. Now both are planets and both are lonely and perhaps a little restless. But the plain physical facts about the celestial body usually do not attract ordinary inhabitants of the Earth. Representatives of mankind love to excite their imagination and try on the conditions of an alien world for themselves. However, we can say for sure, the Venusian climate is definitely deadly for us. Like it or not, but in order to have an understanding regarding this planet, you still have to turn to the official facts. The size of our hot neighbor is just slightly smaller than the Earth, 95% of the diameter of our planet, and its mass is 81% of the Earth's. Accordingly, the gravitational attraction of the object is almost comparable to that which we feel at home. Therefore, if a person had to step on its molten surface, then definitely he would not feel anything like the Martian lightness, where humans will feel just roughly 1/3 the gravitational pull they do here on Earth. By the way, if Elon Musk suddenly decided to drill a tunnel through Mars, then it would take him no more than 3 or 4 days. But I digress. Atmospheric pressure on Venus is the same as that at about 900 meters of ocean depth here on Earth. And that's a lot. That kind of pressure compresses even carbon dioxide, turning it into a strange two-phase substance, what's called a supercritical fluid. It is this monstrous natural pressure that flattened the Venera 4 probe, located at an altitude of 28 kilometers above the surface of the planet. This happened due to a flaw in the machine. The extreme planet's real pressure is 93 atmospheres, which the developers of the device could not even dream of in a nightmare. In the future, when forming and equipping Venusian probes, this parameter must be taken into account. Besides the tyrannical pressure, the world of Venus is also one of a terrible heat that easily melts lead, coupled with a suffocating greenhouse effect caused by an incredibly thick cloud layer consisting mainly of carbon dioxide and nitrogen, as well as being interspersed with sulfuric acid. The atmosphere of the planet is also involved in the making and perpetuation of a global hurricane, one that's been circling around the clock for millions of years. Near the edge of the clouds, the wind speed reaches 140 meters per second, but interestingly, above the surface, the movement of atmospheric flows is almost imperceptible. Also on Venus, thunderstorms sparkle and sulfur rains pour, but they don't corrode the surface of the celestial body, but instead evaporate before ever reaching it. On Earth, a similar phenomenon is called virga. Numerous probes flying past or briefly landing on Venus have allowed us to see this hell, well, at least with one eye. Conventionally, the surface of the planet is divided into 2 continents, the land of Ishtar and the land of Aphrodite. The Magellan probe, having hardly broken through the dense impenetrable clouds, was able to capture some Venusian views. This image shows channels of lava rivers, numerous ancient volcanoes, hundreds of craters, and multiple ridges, including the largest ridge on Venus, the Maxwell Mountains, about 11 kilometers high. For comparison, the highest point on Earth is Mount Everest, whose height is slightly less than 9 kilometers. By the way, this is also the coldest place on the planet. The temperature here does not rise above 380 degrees Celsius, and the atmospheric pressure at the top of the ridge is half that at the bottom, like a mountaintop resort compared to the underworld lying at its foot. The Venera 13 spacecraft gave Earthlings our first color panoramic photograph of the planet, which shows rusty, granular soils and fragments of dark brown basalt rocks, which, by the way, are quite young. They're no more than 500 million years old. The probe spent the longest time on the planet at 2 hours and 7 minutes, transmitting many fantastic images and even unexpected sounds like thunder and strange pops until the merciless climate of Venus interrupted the broadcast. But the most important question that interests the terrestrial community is whether it's possible to settle on Venus, or in other words, terraform it or colonize this recalcitrant neighbor in some other way. Let's try to figure it out. There is an interesting nuance. The vast atmosphere of Venus consists of many layers, the conditions of which differ significantly. Among them, the tropopause is of particular interest to us. According to probe studies, this 15-kilometer deep area is characterized by quite comfortable temperatures, from +20 to +37 degrees Celsius, and pressure similar to that of the Earth. It's here that it's planned to create a flying colony, consisting of huge ships equipped with titanic balls, covered with a protective Teflon layer and filled with Earth-like air. There's also a natural shield from solar radiation in this location. Yes, Venus has an ozone layer. But even this exotic project is not the only one suggested. It's also proposed to install some huge kinds of umbrellas at the Lagrange point between the Sun and Venus, which would significantly reduce the temperature on the planet, making it habitable. In order to enrich our red-hot neighbor with water, it's planned to organize a massive bombardment of its surface with comets and asteroids. True, for this purpose they'll need either a lot of them or just a few really, really big ones. After that, plans will be put into action to deliver specific algae to the Venusian atmosphere, in particular the tropopause zone, for subsequent reproduction. In general, the attractiveness of the exploration of Venus takes place for several reasons. First of all, territorially, because this is the planet closest to us. Also, it's attractive because of the similarity of the planet to ours in terms of weight, size, and indicators of gravity. In addition, if it were not for the dense layer of clouds, then the temperature on the surface of the planet would not be so unbearable. At the same time, there's almost no water on Venus, and the level of radiation is greatly increased due to the absence of a magnetic field and its proximity to the Sun. Therefore, its colonization is a difficult and unlikely event, at least for now. But, as they say, keep dreaming. Moreover, don't forget, even the Earth will cease to exist sooner or later. If this video seemed really interesting to you, don't forget to mark it. Put an electronic finger up and be sure to subscribe to the channel together with a bell in order to be one of the first to know about new releases. We have many more meetings with different mega super planets ahead. Times change. Even for the ridiculously short time that mankind has been on our planet, many events have occurred, flashing like pictures in a kaleidoscope. It's especially interesting to observe attempts to travel various distances that have gone through metamorphoses. Moving on foot, of course, one cannot go far, but gradually people saddled horses, got into cars, launched planes into the sky, and now visiting a neighboring continent no longer seems like a supernatural event as it was in the time of Christopher Columbus. A few more decades will pass, and we'll no longer be surprised by the flights of terrestrial vehicles to other planets and into deep space. But so far, objects launched to study the universe invariably attract public attention. Perhaps the cause of this is not a natural curiosity, more a thirst for knowledge, but the hope that we'll find a new home for ourselves. Be that as it may, on October 15, 1997, when the Cassini spacecraft was sent to mysterious Saturn, humanity could not contain its excitement. Although the main purpose of the apparatus, which carried the 320-kilogram Huygens probe on board, was to study the ringed giant, it also visited the vicinity of Venus, Jupiter, and some moons. Why did it waste energy on this? The answer is simple. These objects are used by astronomers for gravitational maneuvers designed to increase the speed of spacecraft. So what did Cassini look like? What was it loaded with? And what were the tasks facing the interplanetary vehicle? Let's start with the last question first. In addition to entering Saturn's orbit, the craft had an additional goal: to organize a soft landing of the Huygens probe on Titan. The ship did an excellent job on both counts. This is evidenced not only by the studies carried out and the numerous photos of the Saturnian rings and the planet itself, but also by the fact that the Cassini-Huygens survived not for just 11 years, as was originally planned, but for 20. So what were the parameters of the craft? Its weight was 5 tons and 710 kilograms, of which, as already mentioned, 320 kilograms were given to the Huygens probe, 336 to a variety of other sensors and equipment, and 3,130 kilograms to fuel. The height of the craft was 6.7 meters, with a width of 4. The device was equipped with 2 main and 16 additional engines. There were 12 ultra-sensitive instruments on board, including a camera system, a powerful radar, a magnetometer, and a spectrometer. A well-thought-out research and computer base allowed Cassini to hold out for a very long time, extracting a lot of valuable information and photographic materials. This first artificial satellite of Saturn transmitted 635 gigabytes of data and over 453,000 images to Earth. Among these are many unique images previously uncapturable by any device. This brainchild of NASA and the European Space Agency managed to photograph the area between the rings and the giant itself from an incredibly low altitude, as well as a stunning polyhedral hurricane that's been raging for centuries at one of Saturn's poles. The photo of a solar eclipse from a distance of 2.2 million kilometers is world famous. In the photograph, not far from the array of rings, a tiny little point is visible. That's our very own Earth. But one shouldn't think that during the journey to the final goal, Cassini was in suspended animation. In a flash, the apparatus photographed the Masursky asteroid and conducted a photo session near Jupiter, and the images were distinguished by their tremendous detail, capturing elements as little as 60 kilometers in diameter. Flying past Titan for the first time at close range, Cassini recorded a strange formation on the surface of the moon. It turned out to be a cryovolcano consisting of nitrogen ice. In general, the mission, costing $3.26 billion, justified itself with a vengeance. On June 30th, 2004, the Cassini spacecraft nestled into the orbit of Saturn with a stable speed of 15 kilometers a second. The Huygens probe landed on the surface of Titan later, on January 14th, 2005. Until 2008, it was planned to approach many of Saturn's moons, Rhea, Enceladus, Tethys, Mimas, and many others. The device successfully did this, and here is the photographic evidence. The results of the mission are significant and utterly amazing. On September 5, 2005, the presence of mysterious spokes in Saturn's rings was confirmed, stripes that periodically disappear. Astronomers first identified them in 1977. These anomalies were also observed by the Voyager probe in the 1980s, but the origin of the strange spokes has not yet been clarified. Perhaps it's Saturnian lightning. Cassini discovered 7 new moons of Saturn, named Methona, Haliene, Polydeuces, Daphnis, Antha, Aegon, and S2009-S1. The device flew near Phoebe, capturing for the first time the uneven, heavily cratered surface of the object, and also amazed us Earthlings with views of the so-called frozen dumpling, Pan, Saturn's moon, whose size is roughly the same as New York City. The most significant discovery was the revealing of methane lakes on Titan, with one of the reservoirs comparable in size to the Caspian Sea here on Earth. It turned out that winds similar to those on Earth blow on the moon. It also rains there, and thick fogs descend upon its surface. Cassini also observed a giant hexagon, an incredible storm at the planet's north pole. The strict forms of the structure, which is 25,000 kilometers across, are still inexplicable. The hurricane was first noticed by Voyager 1, but it was Cassini that sent clear photos of the incredible storm back to Earth. The Cassini mission was extended twice, but everything must end someday. And so it was on September 15, 2017 at lunchtime. The spacecraft was sent plummeting down into the Saturnian atmosphere. The last minutes of its life were broadcast by the American Space Agency as a tribute to the apparatus, which had faithfully served science for 2 decades. A farewell photo of Cassini has also been preserved, which depicts the impenetrable atmosphere of Saturn. Why did the device die in this way? Several options for terminating the mission were considered. The transfer of Cassini to an elongated orbit, as well as sending it in the direction of Uranus and Neptune. There was also a rather exotic option, the implementation of which it would have been necessary to slingshot Cassini using Mercury. The specified event would have occurred in 2021, as a result of which astronomers would have gotten a chance to get acquainted with the composition of Mercury's rocky surface. But the main thing is that thanks to this mission, which was terribly expensive in every sense, humanity has learned more about the world surrounding the Earth, admired the northern lights at the pole of Saturn, and become familiar with its rings. Neutron stars are the densest objects in the universe apart from black holes. In their cores, it's believed that one can find the most dangerous substance in the entire history of the universe, strange matter. This substance is strange not only because of the name. Strange matter violates the laws of the universe and is capable of destroying everything that comes into contact with it. What a nightmare, you say. But it's not that bad. This amazing matter, among other things, is able to tell a lot about the history of the universe, about its earliest stages. To understand how incredibly strange this matter is, we first need to understand a few basic facts about it. So, what is a neutron star, and how does strange matter break the laws of the universe? A neutron star is the remnants of a giant supernova explosion. The core of the star collapses under the influence of its own growing gravity with such force that it compresses all the particles inside it. Electrons collide with protons and become neutrons. The whole void within the atoms is suddenly filled with particles that aren't really happy with each other's company, but they don't have a choice. They desperately push in the opposite direction of gravity, resisting the collapse. If gravity wins, then meet the new black hole. If particles win, a neutron star appears. Due to this, neutron stars resemble giant atomic nuclei the size of a city, but with the mass of our sun. Imagine that one spoonful of neutron matter on Earth would weigh more than the matter that makes up the moon. Here's where it got strange. Conditions of the neutron star core are so unusual that the laws of nuclear physics change dramatically there. These conditions can lead to the appearance of a strange and dangerous substance, but let's not rush into it. First, you need to remind yourself of the laws before the way to break them. Protons and neutrons are the particles that make up the atomic nucleus. They in turn are made up of smaller particles called quarks. Quarks don't like being alone. You can try to pull them apart, but the more you pull, the more they'll be attracted to each other. If you put a lot of energy into this split, they'd just steal it and use it to create new quarks. Quarks exist only as building blocks for other particles and have never been considered on their own. They're funnily named up quark, down quark, strange quark, charm quark, top quark, and bottom quark. But only two of them are capable of creating stable matter, the up and down quarks. All other variations quickly decay. But this rule may not work inside neutron stars. The forces in the cores of these stars are so extreme that they resemble the processes that took place in the universe immediately after the Big Bang. Thus, understanding the rules by which quarks exist inside neutron stars is a way to plunge into the history of the universe and an opportunity to better understand its ancient nature. According to one theory, inside a neutron star, the nucleus, protons, and neutrons decay, turning into a mass of quarks. A huge number of particles turn into a single object, entirely consisting of quarks. Such matter is called quark matter. A star made up of this matter is called a quark star. In 1970, the idea of quark stars was developed by Toshiaki Ito, and in 1971, Arnold Bodmer showed the possibility of the existence of a strange quark matter composed of three types of quarks. In 1984, this idea gained particular popularity after the appearance of Edward Witten's article on quark grains, clumps of invisible quark matter. According to Witten, such grains, also called strangelets, could have remained in the universe after the Big Bang and formed dark matter. And when combined under the influence of gravity, they could form quark stars. From the outside, such stars will barely differ from ordinary neutron stars. Now we can talk about a very dangerous substance. If the pressure inside a quark star gets strong enough, things get weird. In the cores of neutron stars, some quarks turn into strange versions of themselves. They're significantly heavier and stronger than their normal counterparts. It's their mass that constitutes strange matter. According to many scientists, it's one type of matter that could be an example of an ideal substance, ideal density, absolute stability, and indestructibility. This matter is so stable that it can exist outside of a star, and this is a problem. This perfection is contagious. Therefore, in contact with strange matter, any other matter will try to correspond to it, thus turning into strange matter. Protons and neutrons, of which you and I are made, will begin to decay, joining the mass of strange quarks. The only way to escape this disaster is to throw all this matter into a black hole. You might be thinking, why worry if all these quarks are inside of neutron stars? But what happens if one such star collides with another? They'll eject an incredible amount of their contents before collapsing, including small particles of this very strange matter, which are commonly called strangelets, that is, strange droplet. These particles are able to travel huge distances until they stumble upon a random star or planet. After the collision, the particle will instantly begin to turn everything around it into itself. The collision of a strangelet with the nucleus of an atom can cause it to turn into strange matter, which is accompanied by the release of energy. As a result, new strangelets scatter in all directions, which theoretically can lead to a chain reaction. By the way, the Large Hadron Collider, the pride of humanity and part-time charged particle accelerator, made the best advertisement for the strangelet. Recall that this accelerator was put into operation in 2008 with the participation of scientists from more than 100 countries. Such a grandiose project could not fail to attract the attention of those who were convinced that the experiments could even jeopardize life on Earth. Supporters of the worst-case scenario have long believed that a killer strangelet would be born there and not fly in from somewhere in outer space. This calls to mind the unforgettable novel Cat's Cradle by American writer Kurt Vonnegut, where under the influence of a fictional substance, all the water on Earth turns into Ice 9. Fortunately for you and me, and unfortunately for pessimists, the results of many years of experiments indicate the absence of the formation of stable strangelets as a result of the collider work. But back to the space guest. Imagine that a random planet located in the path of the strangelet is the Earth. Its mass will decrease catastrophically, and everything living and non-living on it will merge into one huge mass of strange matter. If a strange matter particle collided with our sun, then its size wouldn't decrease too much, but its brightness would decrease dramatically. The Earth would simply freeze. Thus, at our current level of technological progress, humanity simply doesn't have the ability to predict or halt this possibility of a monumental catastrophe. A terrible prospect, but there's also another theory according to which particles of strange matter are a common thing in the universe. They do no harm, but quite the opposite. They helped expand the universe during its youthful early years. Perhaps it's this strange matter that acts as the force that holds entire galaxies together. A man with the wonderful name Jingjun Zhang and his colleagues at Nanjing University believe they've discovered strange matter planets made up of the hypothetical strange matter. Their paper's been accepted for publication in the Astrophysical Journal. On average, the planets known to us have a density of about 30 grams per cubic centimeter, but those consisting of a strange substance should be trillions of times denser. Such an incredible density allows them to persist even when they're at extremely close distances from a strange star and rotate a couple of tens of kilometers from its surface without being torn apart by the power of tidal forces. Recently, scientists received a strange signal from the planet Proxima b. What if there is intelligent life there? Do you want to know how this signal was decoded? Subscribe to my new Hubble channel by clicking on the link below this video. I assure you that what we managed to find out shocked the scientific world. The Earth is the cradle of human civilization, but fields, mountains, oceans, and blue skies, the view that we're used to observing from its surface is somewhat subjective. From space, the Earth looks completely different, as evidenced by numerous photographs. Why did we suddenly decide to talk about our own planet? First, it is a celestial body, one of trillions of others in the universe. And secondly, every April 22nd, we celebrate Earth Day. Earth Day aims to draw humanity's close attention to the fragility and vulnerability of our planet. The Earth is a unique celestial body, but in some respects similar to other participants in stellar systems. The third planet from the Sun, the largest of all the objects of the terrestrial group, the same stone spheres like it. Its uniqueness is that the Earth is the only planet known to science on which there is life. Neither on Mars, nor on Venus, nor on Mercury forests rustle, springs murmur, nor human beings swarm like giant ants. Very few of us have managed to see the Earth from above. Those lucky ones, for example, were the temporary inhabitants of the ISS. Basically, Earth was captured by many probes, and not only from nearby. So, how did this long-term photo shoot start? The world's first photo of Earth from space was taken from an A4 or V2 suborbital rocket. It was launched from the White Sands Missile Range and after a while reached the apogee point, located 105 kilometers above the Earth's surface. From there, on October 24, 1946, a series of images was taken, one of which flew around the world. After this, there would be many significant, amazing, and memorable shots, but this one will forever remain in history as the pioneer shot, the very first. Everyone knows that on April 2nd, 1961, Yuri Gagarin became the first person to fly into space. Oddly enough, the astronaut did not take pictures. He only described what he saw on the radio. Therefore, the first astronaut to photograph the Earth was Alan Shepard, who made a suborbital flight in the same year as Gagarin. He took a picture of our planet from an altitude of more than 180 kilometers. After, on August 6, 1961, German Titov, the youngest Soviet cosmonaut, performed similar actions. Check out one of the most controversial photos ever seen of the Apollo 17 astronauts landing in 1972. In it, Harrison Schmitt sets the U.S. flag against the background of a tiny sickle of a distant Earth. For many years, there was a debate about whether it was a staged photo or a real one. History will judge the disputants. But if you look at other images with the image of the Earth and the Moon, then there's no doubt that the events really took place outside of our planet. Let's leave the skeptics alone and turn to other, no less epic photographs. One of the most famous photographs is the Blue Marble. It was taken on December 7, 1972, again by the Apollo 17 crew, after which the photo rapidly zipped around the world. The famous image shows the Earth from a distance of about 29,000 kilometers, generously illuminated by the sun. The next picture clearly demonstrates the change of day and night, the so-called Earth separator. The author of the photograph is one of the astronauts of the Apollo 11 mission. This conventional line passes through every point of our planet twice a day, in the morning and in the evening. Perhaps right now it's just above your city. From what celestial body was the Earth photographed for the first time without taking the Moon into account? It's easy to guess. From our closest neighbor, Mars. The image taken by Voyager 1 in 1977 is not in high resolution, but for the first time, it shows our planet together with its satellite as a space mini-conglomerate. Outwardly, not much different from other participants in the solar system. A curious viewer may be indignant. Why are we looking at ancient photographs? What about modern telescopes and probes? Have they not captured anything worthy of attention? Of course, there are tons of fresh photos of the Earth. For example, a great image of the globe showing night illumination of different parts of our planet is outstanding. This image was taken in 2016 by the Suomi NPP meteorological satellite. As you can see, spacecraft are gradually taking away from people the right to independently document the accessible corners of the universe. The next image belongs to the cameras of the artificial satellite of the moon, Kaguya. In the picture taken in 2008, you can once again see the Earth through the eyes of its faithful companion, the Moon. Exactly 10 years later, the Longjiang 2 probe, which visited our satellite together with the Chinese Chang'e 4 transponder, transmitted several images of the Earth from the lunar surface, including this one. It shows a sharp contrast between two worlds' antipodes, a dead stone densely strewn with regolith, and a living, hospitable planet. Is this really all the documentary footage that humanity has at its disposal? By no means. The Earth's photo session is just beginning, given how many plans to launch unmanned interplanetary spacecraft have been announced by NASA in recent years. In the meantime, let's return to the already existing pictures. Here's the first image. The Discover satellite, located 1.5 million kilometers from the Earth at the Lagrange point, managed to capture a unique scene: the passage of the Moon across the Earth's disk. Voyager 1 is not the only probe that managed to capture the Earth in a lens from the vicinity of Mars. It was also captured by the Curiosity rover from the surface of the Red Planet. This happened in 2014 from a distance of about 160 million kilometers. How about photographs of our planet from surrounding objects other than the Moon and Mars? There are some, and even more than you think. Let's go in order, starting with the first planet from the Sun. On May 6, 2010, the Messenger probe captured the Earth and the Moon from the orbit of Mercury, which is at that moment at a distance of 183 million kilometers. In the photo, both objects appear simply as two bright dots. An interesting story happened in 2013 with the Cassini probe. The device was filming Saturn so detailed and selflessly that the Earth accidentally got into its lens. Of course, the Moon cannot be seen from such a distance. And here's the intermediate result of the OSIRIS-REx probe, which was sent to the asteroid Bennu for the purpose of collecting soil. The first image shows the Earth and the Moon from a distance of 5 million kilometers, and the second from more than 63 million kilometers. But the most distant image of the Earth is the legendary pale blue dot taken on February 14, 1990 by Voyager 1 from a distance of 6.4 billion kilometers. That is near the orbit of Pluto, a lonely, dull, barely noticeable star which is our only home, looks lost and lonely among the universal darkness. Therefore, as Carl Sagan urged, humanity needs to do its best to preserve the fragile balance in the glowing light of life, which for some unknown reason ignited in the cosmic darkness. If you agree with the great scientist, be sure to like and subscribe. The more likes we have, the more interesting content the Hubble channel produces, as it has already happened by tradition. If under this video we manage to collect 1,000 thumbs up, a new, very exciting video will be released immediately. The main thing to remember is, educational videos promote the development of intelligence, and don't you forget it.